Also like,
That's a good day. Little Bucks Day is a good day.
Oh, if it has to pour lunch, then not.
I'll be Brain's Head Friday, does that count as any absence?
I mean, okay, so let's have a quick look. These are just, I've got like 16 problems. Some of them are pretty quick, some of them might take a little bit longer. But let's pull all this stuff together we've talked about with chain rule stuff. And there, I threw in some problems with the new logarithm stuff too, right? The exponential and logarithmic stuff where we got bases other than e, okay? So, talk to me about this one. What are we doing here?
First is gonna be Ellen and natural.
Okay, true, we can. We can use our standard form, but we'd rather take advantage of properties of logs if possible. So what can we do with properties of logs here?
Then natural logarithms.
Good, okay, so we got log of a power, so we can bring the exponent out in front, that helps. Well, that makes this, it doesn't help a lot, it's not like it's that hard anyway, but it makes it a little bit easier. So we can rewrite this as 14 log x, and then we know what's the derivative of log x? 1 over x. So y prime just equals 14 over x, right? No big deal. Yeah. You could have done it, I mean, I waste a lot of time on this, but you could have done it as derivative of log u. Derivative of log u is just u prime over u, right?
X over x to the 14. Or it's next to 13.
And then x to the 13 over x to the 14 just becomes an x on the bottom. But that's a little bit harder, right? We'd rather take advantage of properties of logs. Okay, what about this guy? What's the derivative of e to the u? Times u prime. Good. E to the u prime. So y prime would equal e to the minus 4x times derivative of what's inside, which would be our negative 4. So we write that as negative 4 e to the minus 4x. Good. Okay, so there we go. Well, I guess on that last one, there's the answer. What about this one? So don't say it out loud. Everybody kind of look at this for a second. So this it's a chain rule problem. It's what you might call a generalized power rule function, okay? Where we've got a complicated function to a power, right? So what are we going to do? I've got hand to the 7th.
7 and 6.
7 hand to the 6th. So another thing on this test, it's not asking you to do, if it doesn't ask you specifically to simplify and factor things, you really don't have to do a lot of work to make these things simplified. We're just really more interested in doing the calculus on this stuff, right? So Liz, what's next? So there's our first layer, was the power layer, comes after that. Okay, what's that going to give us? Okay, is there one little thing we got to fix there? Negative sine x. There you go. And that's fine. I mean, that's really, you can just leave it like that if you want to. Okay? Okay. That's technically the answer, but I mean, it's got juggled around just a little bit, but you don't need to. Don't have to. Okay. So, what about this one? There's a lot going on here. So this is one where there's lots of layers to this, to this ogre. We're going to need lots of links in the chain. Miss Skillsdorf.
Oh, God.
On the heels of your stupendous dance performance here, can you tell us what's the first layer going to be?
Well, negative sine of x.
Negative sign of that, right?
And.
Stuff, right? Okay, so I have an outside layer is going to be a cosine layer. And let's go ahead and just peel these layers off one at a time. So we got cosine of 10 e to the x. And so the first layer is going to be the derivative of cosine hand is negative sine of hand. About so negative sine of hand. Next layer, what's that going to be? So we erased this part. Lily, what's the next layer going to be? If I peel that one away, now what have I got?
Negative sine of 10 equal to that.
Okay, so we got cosine of hand, so we got another cosine function. Derivative is negative sine of 10 e to the x. Good, so we can erase that one now. Okay. And what's going to be next here? What do you think? What's next? Derivative of what's inside.
I have a sorry.
So we're just taking, so we've peeled the first two layers, now we're down to there, which is the derivative of 10 e to the x. Okay, so we help her out, right? 10 e to the x, right? 10 is just a constant, so that stays out front. And the derivative of e to the x, just e to the x, right? The derivative of e to the u would be e to the u prime, but the derivative of x is just 1, right? For u is just x, we don't even need it in prime. So that's our answer. We could clean this up a little bit if we wanted to. I mean, we could, like the negative times the negative would become a positive. That would be a good thing to do. We could put the 10 e to the x out front, but otherwise, I mean, we're done, right? That's all we really need to do, okay? And it won't even really have to do that. This is nice. Okay? Questions? Good. I think we're getting the hang of this stuff. This is good. All right, so on this one, what are we going to, Kirk, how do we probably want to rewrite this one to be able to use the chain rule here?
5 plus x sine x to the 1/2.
Good. Okay, so we'd say f of x equals the quantity 5 plus x sine x to the 1/2. And so we're just going to do, we've got a chain rule deal here, but inside we've got product rule going on, right? So what's going on with that one? Are those guys really not showing up?
Does the product will come from the x sine x? Is that where, yeah?
I guess I'll mark them absent. That's crazy.
Well,
So, okay, so what's happening here? Go ahead, Elton, what's going on? So we got a,
So we're gonna take the first layer, which is the whole thing to 1/2, we're gonna get 1/2 times the whole thing to the negative 1/2. And then we'll take the rest of the
good, good. And so what's, negative 1/2 just means what? If I write it as a radical, it's a square root on the bottom, because it's negative, okay? So let's see, Gage, if we look inside there, so now we've taken care of the 1/2 power. What about, that's kind of a little bit of a tougher one. What's the derivative of 5 plus x sine x? It's not so straightforward.
5 goes to 0.
So I goes to 0, what about that one right there? What rule am I gonna have to use there? Product rule, good, okay. So what's that gonna be then? If we've got the derivative, I've got two parts of that. I've got my x times my sine x. What's the product rule gonna tell me?
That's derivative x 1.
Okay, so we get sine x times 1 plus cosine x, good, times x, there you go, good. That's it. Okay, and so we'd want to just, only thing we'd really need to do here, and I honestly think you could leave it like that would be fine, but ideally, we'd like to put the 2's on the bottom, the square root goes to the bottom, and just that stuff stays on top. Okay, and in the future, you will need to make it look like that. All right, so how about this one? So I've got I'll write down the function. What do I maybe want to do with that exponent, Billy? Okay, good, because cosine squared is shorthand for cosine of a function quantity squared, right? We're squaring the whole cosine. So what's the first layer gonna be on this one, Emily?
Do you do the e to the u?
Yeah, so right, so what's the derivative of e to the u?
E to the u.
There you go. Good, so derivative of e to the hand is e to the hand times, and the u prime just means we're gonna, next layer, right? We're gonna differentiate the next layer. So the first layer is gonna be e to the u. I'm gonna go ahead and call that a cosine squared. Okay, Tyler, what's next? So if I peel that one away, exponential part's gone, now what? Okay, so derivative of hand squared is 2 hand. You laughing at me over there? It's probably about the 10th time I've done it, actually. Okay, so we took care of that. So now, Elton, what's the next layer?
Negative pi 2 9
Okay. There it is again. What do you know? Times derivative of cosine of hand is negative sine of hand. Gabe just walked in, I'm gonna pick on him anyway, so what's gonna be the last layer then? We did the cosine. What's the last link in the chain?
Pi.
Pi, exactly. Okay, there it is. And so if I could pull the 2 and the pi out front with the e, and so pull the negative out front too, right? So it ought to look maybe like that. Okay, negative 2 pi,
Or
a little bit, a little bit. Did we, did I write that? Oh, did we missed one, didn't we?
Which one?
Oh, no, we didn't. We're good. We're good. Sine, cosine, no, we're good. We're good. Right? Okay? Okay, it looks terrible, but it wasn't so bad. Right, just lots of links in the chain. Okay, so what about this one here? This is kind of complicated. We've got, somebody break down the structure of this one for me. What's going on with this? Ryan, what's going on? How are you gonna approach this problem?
We have 2 product rules.
Good. Good. So we have 2 terms, right? And so we're always going to differentiate term by term. So we'll take the derivative of the first term by itself plus the derivative of the second term. Each term is a product rule, though, isn't it? Right? Okay, Gage, you're our product rule expert here. You successfully dealt with the last one. So let's deal with this first. You get the first one.
2x times 6 cosine.
Okay. But if we're doing product rule, remember we gotta make 2 terms out of it. First times derivative of the second plus second times derivative of the first.
And then sine 6x.
There you go. So sine, so 2x times, make that yellow for derivative, times sine to the 6th of x. So we did second times derivative of the first. So now we need to do what?
First time dealing with the second.
Okay, so x squared times,
Would you read the 6 right there? Or not?
yeah, so what about that 6? Now remember that 6. What that really means, sine to the 6th of x. And you might want to write this down, but after a while, if you've done this a few times, maybe you start to see that you can just kind of keep track of that in your mind. But really what that is 2 layers. It's a sine x to the 6th.
We're gonna need to add that second layer on.
Say it again.
We only did 1 layer there.
But there was only one layer in that, right? Because we did the derivative of x squared, which is only 1 layer. This one's going to require 2, though. You're right. Okay, Gage. So what's that going to look like then?
It would be cosine to the 6.
So it's, but if we're going to differentiate sine to the 6th, now you got to think about this as chain rule problem, right? So what's the first layer of that chain rule problem?
So 6.
Okay, good. So we're gonna need a 6 times hand to the, good, okay. Now the second layer,
Now because
cosine x, there you go. But it's just a regular cosine x at that point, right? Because we're inside the power function. Okay, good, all right. That's just one layer though, right? So now we've got this plus, and it corresponds to that plus. It separates the two terms. We got another product going on here. So Liz, what about the second product?
X times negative.
Okay. -6 times,
These numbers were wrong.
so we're on this one now, right? So we did the first, so all this stuff over here, these are the two terms from the first product. Now we're doing the second product. So you're off to a good start. So you said x, and you're doing the derivative of that part, right? So what's that?
Times this side, just
Cosine, what's the power going to be?
negative 7.
-7, there you go. Cosine to the -7th of x plus, oh, whoops, yep, sorry, we missed a step, didn't we? Whoops, times the derivative of the cosine, which is negative sign, there you go, good. Plus, good, there you go, times 1, okay? So it's a lot of stuff. What could we do? What could we do for the first two terms? If we split this up, those first two are going to go together pretty well. And you know, how do you want to, I mean, this,
Factor out x sine x, so that,
Just try it out.
and it's, factor out 2 as well.
yeah, it's, I mean, I don't even know how much, let's see what they have. And once again, I don't think, it doesn't tell you on these that you have to really do anything special, so I don't think I even would try to factor stuff out. I think I would just leave it like that. I think we're fine, combine.
Why is it?
But there aren't any like terms,
Oh,
so there's nothing to
there's a
combine.
-1 and a -1. So,
Oh, you mean, okay, multiply those out, good.
Yeah.
So we could do a little bit, like this one looks pretty good, doesn't it? That first term, 2x sine to the 6th of x. Here we could put the 6 out with the x squared. And then we've just got sine to the 5th of x, cosine x. Here we got a negative times a negative. We can take the 6x out front, so that's a plus 6x. Cosine to the -7th of x, sine x, and then finally just a plus cosine to the -6 of x. So I don't know if that's exactly what they got or not.
It
That's
is.
good enough.
That's exactly what I got.
Okay.
Just reversed.
Some terms are interchanged, but big deal, right? Okay? Yikes. Okay, but what are we probably gonna wanna do with this before we do anything else first? Properties of logs. We wanna take advantage of those properties of logs to make this simpler. Okay, so Elton, give me one thing, the first thing we're gonna do to make this simpler.
We're gonna take that to natural log of 3, move that to the front, and then with mark this
Okay, so we've got the log of a power, so we can take the exponent out front, that's good. All right, so we end up with natural log of 3 times the base 3 log of 81t. Anything else? Kurt, see another property?
could you separate 81?
Yeah, we get a log of a product, we make that a sum of the logs. So next step, we've got natural log 3 times the quantity,
Basically,
there you go. Base 3 log of 81 plus the base 3 log of t. Personally, I wouldn't even worry about that though, because when you differentiate this, the base 3 log of 81 is just a constant, no variables in there, right? So we don't even really have to simplify that. We just know that we're gonna end up getting, that's gonna go to 0 anyway. So So at this point, we could probably just do, take y prime. So y prime is gonna be, we've got a log 3 out front. This one just becomes a 0. I'll write it as a 0. Plus, question, comment? No. What about this then? What's our new rule? So what's our standard form for the derivative of a base A log of u?
U cross over ln of,
A.
A times U.
Right? That's our new standard form. So we just apply that and we get,
Natural log.
good, so we're gonna get u prime is just 1 over
ln of 3
times
log base 3
times
t of t minus.
t, not log, yeah.
That would know that.
Okay, and so then, that's gone. If I just distribute the log 3s, everybody see that the log 3 there cancels with that log 3, so what's my answer? 1 over t, what do you know? Okay, no biggie.
So,
Okay, questions? Yes.
It's weird, but would there ever be a benefit just to like, separate the 81, make it like log 3 of 9, choose 9 or something?
Yeah, there could be. I mean, we could do, yeah, so
Yeah.
the answer is yes. Like, what if we just took the log, the base 3 log of 81, just by itself, right? How can we simplify that? A couple ways we could think about this.
Basically, log of 9 squared.
So you could think of this as being, well, I would even say 81 is not just 9 squared, it's what?
3 to the 4th.
3 to the 4th, right? So we could rewrite this. One way to do this would be to write it as the base 3 log of 3 to the 4th, and what's that?
4.
Yeah, right, because I'm taking a base 3 log of a base 3 exponential. Everybody see that? And so that's just gonna give us 4, okay? Honestly, what I would probably do with this, and I'm not saying this is the smartest thing, but if I just saw this on a test, I would probably just rewrite that as natural log of 81 over natural log of 3. And then I would just make that 81 into I would do the same deal with it, right? I would just make it a 4 log 3, the log 3's would cancel, right? I don't know, that's no better. That's what I would have done. So either way, we just do 4. Okay? So this is just a pretty straightforward, there's really no fancy property of logs I can do there, is there? Everybody agree? We're just stuck with an a to the u, so we need our standard form on this one. What's that?
For some reason yesterday on the assignment, I thought the 9 was G. So I kept
Oh,
putting-
serious?
I kept putting a G in for all my.
Oh, okay. See that, I guess? Can see that, all right. Okay. So what's our standard form for the derivative with respect to x of a to the u times, well,
Times U.
times what?
H
A to the u. There you go.
D.
Right, so it's the normal, times u prime, right. So it's the normal pattern that we get with an e, but we gotta multiply by a natural log a, that's what makes it a little more complicated, right? That's how I remember. So then, this is just a straightforward application of that. What are we gonna get? Whoops, that's bad color. Y prime equals natural log 9 times 9 to the base 4 log of t, but what's our u prime gonna look like? Like, there's our u. So now we're going back to one of those guys, right? Okay. So what do we get?
L and then 4 T.
So 1 over natural log 4, so u prime, derivative t is 1, over natural log of 4, because that's the base of the log, times u, which is t. And so we could simplify that a little bit, I guess, to make it look like that if you wanted to. And what did they, okay, how did they get, you don't have to do this, but how did they, what'd they do here? So let me rewrite this one step. So we had something like this. We had,
Oh, they did the
9.
reverse of that.
So they did the reverse of what we were doing.
Yeah.
so what they're saying, yeah, let's define that. So then they took this part written in pink or red, whatever you want to call this, the natural log 9 over the natural log 4. And all that is taking advantage of the property that the base A log of u just equals natural log u over natural log A. And they just did that with them. Right? If I've got a quotient of logs, the argument of the bottom log becomes the base. The argument of the top log becomes the argument of the new log, right? No, it's fine, just like that's fine. You don't have to do that. That's fine, either way. Okay? All right. So we could have left it, this would have, in other words, just make sure you get this. That's fine, no problem. I like it. So let's see, that gets that one. Take a second and just think about that. Maybe you can get out your notebooks and just scratch a little something down on that. The log of what?
Log base X.
Log base x. So we don't have that technique yet. That's coming later. That's coming after our next section. We'll add another technique we can use for things like that. But we can do this one still. Because I've got a log of something here, right? So what can I use property of logs to do? I can take out the exponent, can't I? Right? That can come out front of the log. So one way I can do this is I could rewrite this as natural log 8 times the base 8 log of all that stuff, right? Okay.
I would think that is a draft.
You certainly could. You certainly could. Does anybody see another trick here that might, and that's fine, there's no one way to do this. I'd argue maybe there's a slightly better, easier way. But then we could just leave that natural log 8 out front, that's just a constant. And then this becomes, you could look at this just as being that type of problem, right? A base A log of u. Agreed? Where u is a quotient. It's fine, you could do that. You're already seeing that probably it's a lot better. Why not make that a difference, right? Use the property that the log of a quotient equals the difference of the logs. Split it up. There's something else you could do here that would make this look better too.
Did you use natural log?
Yeah, good. Let's convert this. Let's convert the base 8 log into a quotient of natural logs. Everybody see that? So we could take this thing right here, and we could write that itself as the natural log of the quotient divided by the natural log of the base, right? Do you have to see that? No, you really don't, but it sure does help, doesn't it? Because then the natural logs cancel. The natural log 8 cancels with the natural log 8, and then you've got a natural log function, which is easier than a base 8 log to deal with, right? So these guys, so we end up then with Let me write this out just so. Those guys cancel, right? And then, now we can split that up, right, into a natural log of x plus 5 minus a natural log of x minus 5. That's pretty easy, right? So y prime. What's the derivative of log u?
U over U, U prime over U.
U prime over u. So we're just going to get a 1 over x plus 5 minus,
1 over X.
and that's fine. Just leave it like that. I mean, technically, you could add those fractions up, but we don't need to worry about that. They did, but, I mean, you see how you could. Just multiply this one by x minus 5 over x minus 5, multiply this one by x plus 5 over x plus 5, right? But it doesn't ask you in this problem, I didn't copy the text of the problem, but it doesn't say to do that. It doesn't say to simplify the problem. These really don't, so you don't really have to. I think I'll show you. Does everybody see how that works? Give me a 1 to 5. 5 meaning Mr. Roy, I totally get how you get to there from there. No need to look at it. 1 meaning don't see it at all. Somewhere in between meaning wouldn't mind seeing it. Okay, so let's do it then. So all we would do, because this is the kind of stuff we will be doing in the future more and more. I'm not going to hold you accountable for it on this test, but eventually you're going to want to be able to do this. So what happened there? That's the glitch. The glitch in the universe right there.
First is broken.
The universe is broken.
Artificial simulation.
Right? So we're just multiplying, we're getting a common denominator. So on the bottom, we're going to get an x plus 5 times x minus 5. Resist the temptation to multiply that out, because we'd rather have it factored anyway, right? On the top, we're going to get this part minus, why are my colors not working here? Minus this part. So minus the quantity, x plus 5. That part minus that part, right? And so if I just distribute the negatives in combined like terms, I get x minus 5 minus x minus 5 over my common denominator. And so the x's cancel, and I end up getting my, somewhere, that guy, there it is. Right? Took a circuitous route to get there, but I got there. All right, so everybody see that? There's my negative out front, my negative 10. Okay. Simple, simple. Right, I mean, we kind of already did one like this, really. So we'd use the property of log first. What would we rewrite that one as? I don't know why you put this one on here, this is redundant. I'd rewrite that as 4 log t, right? Good. Differentiate, I'm just going to get 4 times 1 over t, so 4 over t. I mean, what am I going to do here? I mean, you have to even mess with this. I'm going to get 4 times the log of
4 over 11.
4 times log 11 minus log x, so 4 times that quantity. Differentiate. I'm just going to get that, right? So log of 11 is a constant, so when I differentiate it, it goes to 0. You want to see that one? You want to see that one? I think we've done some like that already today. I'll skip that one so we can get to everything else. Okay, so this is a little tougher. This is a chain rule one, isn't it? Right? I got a log of hand, and hand is a log also, right? So first layer then, let's write the function out. So first layer to this then. Katie, what's my first link going to be? So I got derivative of log hand, which would be So it's kind of hard to write these separately, isn't it, really? So I'm going to get hand prime, we'll leave the space, divided by hand. Okay, so I'm going to get my 2 out front, my constant, and then I've got my u prime, which we have yet to do, over my 4 log x. Okay, so now we got to look at u prime. So we did the outside layer, and we're left with u. What's the derivative of u? Basically, what's that going to be? So the derivative of 4 log x is 4 over x, exactly. Right? Right? That makes sense? So the derivative of, once again, we had the 2 stays out front. We're really just doing this. The derivative of log u is u prime. There's my u prime, right? Divided by u. Okay, so we could simplify that a little bit. We could rewrite that as 2 times 4 over x and multiply by the reciprocal at the bottom, so I get a 1 over 4 log x, and so the 4's cancel. I end up with, on the top, I've got a 2 if I multiply across, and on the bottom I've got an x log x. Anybody see that? This is, I mean, I can see why this one's kind of a brain bender a little bit, because the u is a log. But it is, the derivative of log u is just u prime, which is in yellow, divided by u, which is in white. Okay? And, oops. That's what we got, right? What are we doing on that? Good? Okay. So, just, more chain rule stuff. Well, we got a couple more to go, and then you can have tomorrow to just study. So remember, we're going to do, the practice test is up. We'll go chain rule test Friday. And then last week before Christmas, I got a couple little things to show you. Maybe we'll take a day at the end and have a universe talk or something on Friday. How about before Christmas? Happy birthday, yeah. And for your present, I gave you the gift of calculus today. I hope you liked it.
So, I don't know if you've